Hello everyone, so in this video I'm going to go over the review sheet for your test. The first question asks you to find the value of cosecant given an angle theta on the unit circle. Now, all you have to really know for this question is that cosecant is the reciprocal of sine. This is really 1 over sine x. And sine is the y coordinate of a xy coordinate on the unit circle. Remember, x is cosine and y is sine. So all you have to do is take the reciprocal of this guy, and you'll get negative 3 over rad 8, and that's your answer. Next question says, write a sine function that has a amplitude of 5, and a shift to the right of pi over 4. So we're going to do 5 in the front, then sine of x minus pi over 4. Remember, when you shift to the right or left, it's on the inside of the parentheses. Minus means right on the inside, and positive means left. Next question asks you to find the values of A, B, and C. So basically they want you to find the amplitude, which is this guy, the frequency, which is this guy, and because it's added to the end, that's the midline. So I'm going to first find my midline because that's easiest, and I can see that it's at 3 because it's up 2 and down 2. Now that kind of gives you the answer. This is C is equal to 3, and because this is 2 up and down from the midline, A is equal to 2. So the only choice that has A equal to 2 and C equal to 3 is choice 1. To explain this guy here, the B values are frequency, and the formula for frequency is 2 pi over the period. The period of this graph is from here to here, because that's one full curve. So that stops at pi over 3. So if you do 2 pi over 3, you would get 6 as an answer. Next question says, write this as a single term with a rational exponent. So I'm going to write this with power over root times x to the power over root. This is a root of 2 because it's a square root. The powers are both 1 because they're not there. And then you have to remember that when you multiply, you add exponents. So you're going to do 1/4 plus 1/2 up here, which you can type into your calculator or get common denominators. Do not make this 2 over 6. That is completely incorrect. This would reduce to 3 over 4 when you add them together, because you'd have to make this 4 over, well, you have to make the bottom 4. So this would become 4 on the bottom. That's times 2. This is times 2. And then 2 plus 1 is 3. And that's how you get 3 over 4. Next question. Right away, I see fractions, I see radicals, so I'm thinking quadratic formula, which is on your reference sheet. And to do that, I have to make this equal to 0. So 3x squared plus 2x plus 7 equals 0. And then I'm going to do A, B, and C inside my quadratic formula, which is x equals negative b, so negative 2 plus or minus the square root of b squared, so 2 squared minus 4. A is 3 and C is 7, all over 2A, which is 3. Again, this is the formula on your reference sheet. Put parentheses around this because you might not have a positive. So negative 2 is going to stay the same. This will become 6. And then plus or minus square root of this, just the inside of the radical, becomes negative 80, I believe, which splits up into 16 and 5. And I'm going to reduce this to 4. The rad 5 will stay. And we got this negative under the radical, which means I comes out. So we have negative 2 over 6 plus or minus 4i rad 5 over 6. This reduces to 1/3. That reduces to 2 over 3. So this is your answer here. Just so you know, I could have known that this was my answer at this step right here, because in this step right here, I saw a negative under the radical, which means that an I would come out, and that's the only answer with I. So just a multiple choice technique there. To do this one, you're going to have to go to your calculator and press second, matrix button. Then once you're in matrix, you're going to hit math, and you're going to scroll to find RREF. That's going to pop up on your calculator, and then you're going to hit alpha zoom. And you're going to type all the coefficients in. So you're going to type 1, 5, negative 1, negative 20, 4, negative 5, 4, 19, negative 1, negative 5, and 2. And you'll find out that A equals negative 2, B equals negative 3, and C equals 3. They want the one that's not. So the only one that's not is 2. Okay. Next question asks you to draw a graph of 3 tan x and then describe what happens as it decreases from pi to pi over 2. So first off, I'm going to make my xy axes. You can type this into y equals 3 tan x. We're doing this interval of 0 to 2 pi, so 0 to 2 pi, 1, 2, 3, 4, 5, 6, 7, 8 pi. 1, 2, 3, 4 will be 3 pi over 2. And 1, 2, 3, 4 would be pi over 2. 1, -1, and so on and so forth. Now, typing this into your calculator into y equals, make sure you change your window so that the x min is 0. So let me write this over here because I don't have my calculator here. X min is 0, x max is 2 pi. The x scale you're going to definitely want to be pi over 2. And then y min, y max doesn't really matter. I'll do -4 and then 4. And then you'll be able to see a graph on your calculator. You should notice that there are asymptotes on this graph at pi over 2 and 3 pi over 2. And here's the thing. It crosses at 0 here, here, and here. You can see that on your graph. But there's one other point that I'd like you to graph, and that's the one in between. And that actually happens to be 3. It goes up to 3 because this one was multiplied by 3. So it's just going to stretch the graph a little bit. And then this will go down to -3. I know this graph doesn't have an amplitude, but at least it tells you the halfway value. That should be more curved if you guys can see it. I didn't really do a good job with that one. And then, yeah, 3 down from here. They ask you what happens when you go from pi to pi over 2. And when you look at the graph from pi to pi over 2, let me get a highlighter. You can see that the graph decreases without limit. So it keeps going down, down, down forever and ever. So I would say the end behavior decreases to infinity. I'm not going to type that because it will look very bad. All right, next one. System of equations. So the processes that you have are either set them both equal to y and set them equal to each other, or substitution, which might be easier with this one. I think it might be easier to take this guy here, and because it's equal to y, plug it in for the y here. That's what I did, but you could definitely set the second one equal to y and solve that way. Okay, so I'm going to go ahead and put that in there. So I'll get x squared plus 4x minus 1 plus 3, because this is where I put y. So if you can see it, maybe it'll be easier if you can see it better if I highlight it. This was the y that I put in, and the plus 3 and the equals x stayed the same. Okay, so we're going to combine our like terms, these guys here, so that would get you 2. Then x squared plus 4x equals x. Subtract x over, and that'll get you, we'll move over here because I'm running out of room, x squared plus 3x plus 2. And then am. This is actually a nice am. It's just plus 1 and plus 2. And then you gotta find x. But we want to find a solution of the system, which means you need x comma y. So -1 comma something and -2 comma something. To find that comma something, use this guy right here, or the other one, but it's easier probably to use the y plus 3 equals x. And you're going to do the two scenarios. So the first scenario is with x equal to -1. So I'm putting it in for x, and then that would get me -4. And then let's do the other scenario, y plus 3 equals -2. And subtract the 3, and then you get -5 over there. So just check that these points even exist on these two things. You can plug that into y equals, another guy into y equals, and see if you get those answers. They ask you to graph this on the same interval of -2 pi to 2 pi. So first off, 1, 2, 3, 4, 5, 6, 7, 8. This has to go in the middle because we're going from a negative to a positive value. We're going from negative 2 pi to 2 pi. So for those of you who are using the calculator, what this means is that my x min will be negative 2 pi, because that's what they said here, and my x max would be 2 pi. X scale I would still keep as pi over 2. Remember, this is my window set up right now. My y min, y max doesn't really matter, but I'll keep it as negative 4 to 4. And then you can type in both of these guys. I would do one at a time. But for the sake of for the fact that I have no calculator on this iPad, like no calculator app that you guys will see me graph it, which kind of stinks, I'm going to show you how to do it without it. Negative 3 pi over 2. Move this up to 4 and down to negative 4. Okay, here's the deal. What's easier to do is actually to graph cosine and then do secant. Okay, so cosine, remember, starts at its max of 1, and we'll just do the one side at a time. Goes to 0, then goes to negative 1, goes back to 0, and then goes to 1. And that's one cosine curve right here. Don't really like that. Okay, better. And then same thing over here, just reflected. And then let's do our best to make it look wavy. Okay, so that's cosine. And then to do the reciprocal of secant, wherever you see it hit the 0 is where an asymptote is. So here, here, and here, because that's where it crosses the x-axis. And then to get the other part of the graph, all you got to do is very simply put a point here and then go up, put a point here and go down, put a point here and go up, put a point here and go down, and put a point here and go up. That's how you do it without the calculator. Okay, over the set of integers, factor this guy completely, so GCF first. And then AM. This doesn't look like AM because of the x to the fourth, but since I can break it up into x squared and x squared, it is GCF. I'm not sorry, it is AM. Factors of 12 that add to 6 are add to 4, I'm sorry, are negative 6 and positive 2. That's done. I think that's it for this page. Okay, next page. The depth of the water on the shore of a beach varies as time goes in and out. Can be modeled by a cosine graph. A sailor studying the tide charts in constant area, what does this amplitude, period, and midline represent? So it's the sailor. So right now let's just visualize the water. I'll do blue, high tide, low tide, high tide. So if you think of this as the max water level and the min water level, that's helpful. And then it'll continue, you know, forever and ever and ever and ever and ever because it's a constant rate. The middle, right here, is the midline, which is the average water level. This is your midline. The A is this distance from the midline. And the period is how long it takes for this to happen, for the whole full cycle of max to min, high tide, low tide to happen. And that's basically it in words. I'm not going to write it all out, so let me just say it in words. The amplitude will represent the maximum and the minimum values from the midline, which is the average water level. So again, amplitude is going to help you find the max water level and the min water level. So the high tide and the low tide from the midline, which is the average water level. And then the period is how long it would take to complete. The key word here would be one full cycle of a tide. So from the high to the low to the high. Next one. This one says that this is in quadrant 2. So what you're going to do when you have this question is you're going to make a triangle in quadrant 2. So boom, boom, boom. We'll make theta here. This means this is the hypotenuse, this is your opposite because it's across, like a diagonal from it, and this is your adjacent. They gave you tangent, which means TOA. So they gave you the opposite, which is 8, and the adjacent, which is 15. This is negative technically because you're on the negative side of the xy axis. Now they want you to find the value of sine. Now to get the value of sine, you need to know sine of theta equals so in SOHCAHTOA. So, so you need to find these two pieces. So sine of theta would equal, I know O is 8, but I don't know the hypotenuse. So this means I got to find it by doing the Pythagorean theorem. So I can do that over here, a squared plus b squared equals c squared. And then a squared is, doesn't really matter, just a leg. So negative 15 squared. Make sure you have parentheses around that because it's negative. 8 squared equals c squared. And then this, I think, combines to 289. And then square root 17. The hypotenuse will always be positive, by the way, and this is your answer. Beautiful. Next one, we're going to graph this guy on the axes below between 0 to 2 pi. So I made this 0, and I made, get rid of this guy, I don't know where that came from. And I made this 2 pi. And, you know, it's symmetrical, so I'll go, I think it's 20 across, so 10, 1, 2, 3, 4, 5, 6, 7, 8. You do not have to, pi, you don't have to scale this way. You could do 2 pi a little bit farther in, which might work out better, but I'm already committed, so I'm staying here. 1, 2, 3, 4, 5 would be halfway here. And then 1, 2, 3, 4, 5 would be here, pi over 2. You don't have to label all of these. I mean, I'd hope that you know all of them, but if you don't, that's fine. Now, we have this equation here. And of course, you can put it into the y equals. This would be your x min. X min would be 0, because they tell you x max would be 2 pi. And again, your x scale should be pi over 2, because that's what we got going on here. And then your y min, y max depends on d plus a, d minus a. So d is actually a negative 3, so it'd be negative 3 plus or minus a, which is 4. And it's already absolute value because absolute value means positive, so 4 is positive, so there we're good. Negative 3 minus 1, well, negative 3 minus 4 is negative 7, so that's your y min. And then your negative 3 plus 4 is positive 1, so that's your y max. Okay, again, you of course can use your calculator while using this window and everything like that, but since I don't have a calculator here, I'll talk about doing it without it. So what I would do first, me personally, is I would plot the midline of negative 3. Since I'm counting normally on the y-axis, I don't really have to label it, but if you want to label it, go for it. And then I'm going to fit sine in here, but twice, because my b value is 2, which means that we're going to see 2 full sine curves from 0 to 2 pi. So one of them is going to happen between here and here. So let's do that first. Sine has zeros that are 3 of them, and it would happen in the middle. And then halfway, perfectly halfway, so this would be, since this is 1, 2, 3, 4, 5 boxes, it's actually 2 boxes and a half, which is not ideal. But we can do 2 boxes and a half and count 4 above, because that's my amplitude. 1, 2, 3, 4, there's my max. And then 2 boxes and a half from that next 0 and count 1, 2, 3, 4 below, which should be at negative 7. Negative 4, negative 5, negative 6, negative 7. Yep. And that's curve 1. And then I'll just do the same thing here. 0, 0, 2 boxes and a half. We're going to go up to the same value of 1. That's 4 above the midline, and 2 boxes and a half, and 1, 2, 3, 4 right there. Good job. There we go. Saying good job to myself. Good job. Okay. Let me show you the graph one more time. There it is. Ta-da! Okay. This one here. Why can't I zoom in? Oh, that's really zoomed in. Oops. Okay. They ask you here to graph a quartic polynomial that has these zeros. So if you want an equation and you can't do this without an equation, you can go backwards if you know these are the zeros and just put them into an equation. So this is h of x, they're naming it. So this would be x plus 1 times x minus 2 times x plus 3. No, that's wrong. X plus 2. And then x minus 3. So you could just do that and get an equation and get the answer, like get a graph at least. Now on, oh, nothing erases when you need them to, does it? Ignore this little thing I put there, that little tick. I don't know what happened there. This guy, that's really not there. I don't know why it won't go away. So you could put this into y equals and see a graph, and it will help you. Otherwise, you can just eyeball it. So me personally, I like to make things a little bit more exact. So because I know these are my zeros, what you can do is multiply all of them, actually find the y-intercept, which gets you 12. So, or you can just plug this in and find the y-intercept that way. So I'm going to plot that when I get that. But really what I'm looking for with this question, I'm looking for you to cross at -1, at -2, at 2, and at 3. And then just make a graph that goes like something like this. Woo, going through all of them. That's even fine. But me, I know that these are my zeros, and if I multiply all of them, I do get 12. So I'm going to go ahead and put it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's how you get your y. Hopefully I counted that right. Doesn't really matter though, because this is still acceptable as long as my zeros are right. And I put my arrows at the end. Ta-da. Okay. That's that for this page. Okay, last two questions. Woohoo, we made it. Okay, so the water peak demand for this summer month town has this equation. A, B, and D are here. They want you to graph it from 0 to 90. So my x min is 0. It says right there too. And my x max is 90. Doesn't really matter what you scale y by. I suggest counting by ones because this is a x scale should be 1 because it's a real life problem. Your y min, y max is that d plus a, d minus a absolute value thing. So remember, it's d plus or minus the absolute value of a. The a is not negative here, so you don't have to worry, but if it was, it would become positive for this to work. So you're going to do 5,000 minus 1,600, so that gets you 3,400, and 5,000 plus 1,600, which is 6,600. And you're going to graph. You're going to type it in your calculator. You're going to label this 0 to 90. I would at least label halfway. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think this is 45. 1, 2, 3, 4, 5. You can put a little tick there. You don't have to label it if you don't want to half that number. 1, 2, 3, 4, 5. Normally you're going to want to see these 5 tick marks because those are where the key values of the function happen. But because we're only doing 90, you're actually not going to see the full sine curve. Okay, so now let's do the y-axis. First off, this is days, so I'm going to label this because this is a normal problem. Days. X is days in this. They say T is days, I think, somewhere in here. WT represents cubic feet, and then 30 days, and T equals 1 is June 1st. So yeah, this is days. Okay, now my y-axis. I'm gonna break this right here with a little squiggle. Looks really good. And I'm gonna make this bottom part 3,400 because that's the min that we got, and then I'll make the top, very tippy top, the 6,600. Okay, so that's great. And then halfway I'll do my midline, which I think again this is 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm too zoomed in again. And then this is 5,000. And then we'll do WT, which is water and cubic feet. So feet cubed. And then I'll plot. So type in your calculator, look at the graph, and you're going to see that it looks like this. It goes here, here, and then halfway it goes to its max, and then beautiful, we have a graph. Woohoo! Alright. Looking great. Then they ask you identify the period, midline, and amplitude of the function. So the period is 2 pi over b, which is b is pi over 90, which gets you 180. technically days. You should label this in real time. Midline, because it's a real life scenario, we're going to write 5,000 because that's the D value, and feet cubed because we're dealing with, that's the y-axis. And then your amplitude is that A value, which is, what is it, 1,600. And then we'll label that cubic feet because that has to do with the y-axis. What date is the water the greatest? It's here at 45 with the max. So 45 days since June 1st. They tell you that June has 30 days. This means we're at July 15th because 30 plus 15 is 45, and that's July 15th. How many cubic feet are needed? So the maximum on that day is 6,600 feet cubed. Last question. On July 21st, 2016, the water level in the Puget Sound was at a low of 2 feet at 7 a.m., so low tide, and then a high tide of 12 feet high at 12:30 p.m. So this is low at 2 feet and a high at 12 feet. I'm just trying to make myself a visual here. This happened at 7 a.m. and this happened at 12:30 p.m. They want you to write a cosine function in the form of a cos b t plus d, where a, b, and d are real numbers that model the water level and inches above or below the average Puget Sound water level as a function measured t hours since 7 a.m. This means basically there's no x or y shift. Like this is 0 technically in our scenario. So we have to fill this in. So f of t equals a is your amplitude, b is something, and this is something. So we're going to first find our midline. So the best way to find a midline is to remember that it's the average. So if you just do 12 plus 2 and divide that by 2, you'll get 14 over 2, which means 7 feet is here. You could probably figure that out without me doing that math. And then 7 above and below this is just 5. So the amplitude should be 5, but be smart here. This is a negative cosine curve. If I continue it, you'll probably see it. It's frowning. So if you don't have that negative, that's a problem. And then last thing you got to do is find the b value. And to find the b value, we would have to do 2 pi over the period. Period is how long it takes to make one full cycle. Now, right now, we know that it takes this long to make a half cycle, and then we'll just double it to find the period to make the full. 7 a.m. to 12:30 p.m. So 7, 8, 9, 10, 11, 12. I'm a child, I need to see it out. 1, 2, 3, 4, 5, and then a half for 12:30. So 5.5 hours for half of this, and then 5.5 for this half. So together, we have a total of 11 hours, and that's your period. So 2 pi over period would be 2 pi over 11, and there you go. And that is your review sheet. Good luck, study, come to extra help, and I'll see you soon.